discussing about the computer registers. What are the special purpose registers are required for the designing of a basic computer. Now we are going to be discussing about the how these registers are interconnected interconnected within the processor, simply in the processor. This is known as the register common bus. So our topic is register common bus in computer organization. Here we are going to be observe there are several common buses in the computer organization, right? One is about the common bus which connecting the all components within the system. The second one is the construction of or designing of common bus by using multiplexers and three state buffers. The third one here we are going to be discussing about the register common bus. That means how these registers are interconnected. So once again, for our knowledge purpose, what are the basic special purpose registers for the computer? I will discuss. There are 8 registers are required for designing of the computer. The first one is the address register, which consisting of the 12 bits. The second one is the program counter. It is also the 12 bits. These two registers consisting of representing the address of the memory locations. Right? The third one is the instruction register to hold the instructions. This is 16 bits. The fourth one is the data register to hold the data fetched from the memory. This is also the 16 bits. The fifth one is the processor register accumulator. This is also the 16 bits. The sixth one is the temporary register to hold the temporary results or intermediate results. This is also be 16 bits. The seventh one is the input register INPR. This is 8 bits. The eighth one is the output register OUTR. This is also the 8 bits. Friends, for ease of remembering, I write in a bitwise manner. The first two are the 12-bit registers. The remaining four are the 16-bit registers, and the remaining two input-output registers 8-bit registers. Why these some of the registers are 12 bits means the address or the length of the memory address is 12 bits. We know that the size of the memory is 4096. That means this is the 0 location, this is the 4095 location, totally 4096 bytes. Right? The length of the location is the length of the location is 16 bits. Hence, to represent this address, we need 12 binary bits. That means 12 0 0 0 0 0 0 0 0 0 like 12 zeros. Right? That means 2 to the power of 12 equal to 4096. That is the last one is 12. 1, 2, 3, 4, 12 ones are there. Right? So for that reason, the address memory address consisting of 12 bits. Hence, the program counter, which holds the address of the next instruction, and address register, which holds the address of the current executed instruction, has the 12 bits. The remaining consisting of the data because our instructions, this is the 16 bits length. The data and instruction has the 16 bits length. Hence, the 16 bit registers input and output, that is only 1 byte. So 1 byte means 8 bits. So these are the 8-bit registers. Now I am going to draw how these registers are interconnected. Right? Please observe carefully. We have the memory. We have the memory. So at the top, we keep the memory. So this is memory. That is a 4096 by 16 bits each. And then we are going to be right to fetch the instructions or data or instructions from memory. We need the address of the memory location. Hence, below that one, I draw the address register. Right? By using this address, we fetch data and instructions from the memory. Right? For the address register, address is supplied from the program counter we already discussing, that is PC. So below that one, I am going to be write the PC program counter, right? Program counter consisting of the address of the next instruction. Suppose we fetch the data from the memory by using this address. We store the data within the data register. Hence, below that one, I write the data register. Right? After fetching the data, we are processing the data. Hence, below the data register, I am going to be write the processor register, that is accumulator. Remember carefully, for this processor register, we are attaching the one more, that is ALU, that is arithmetic logic unit. We know that all the arithmetic logic and shift operations are performed within ALU. Hence, the data from the data register is transferred to the ALU, right? And ALU is also consisting of one more small flag, one more small bit, that is known as the some extra bit, that is E. What do you need of the extra bit means, suppose we are going to be add two numbers, that is 72 and 86. For example, this is 8, this is 15. The one extra bit, that is overflow bit, that is for the ALU. And this ALU also consisting of one more register, that is directly, that is input register. Sometimes the input is directly transferred from the input register to the ALU, and repeatedly the calculations are performed. Hence, the output of the accumulator is again connected to the ALU. After that one, suppose we are fetch the instructions. The instructions are keep within the instruction register, that is IR. After the instruction, suppose is there any temporary results are there during the calculation, that are stored in the temporary register TR. And finally, the output register OUTR. OUTR, that is in the processor. So how these registers are interconnected, don't worry. All these registers are connected like that. Like that, let us consider this is the common bus. That means bus means we know that the set of lines, the set of lines. This is connected like that. We draw the line like in U shape, right? Like in U shape. This is the common bus, friends. For this common bus, we are connecting all the registers, including the memory, right? Up to top. We are draw this common bus. We draw this common bus, right? This common bus has three selection lines, right? To select which register, right? This is the common bus, three selection lines, S0, S1 and S2. By using three selection lines, we are going to connect it. So this is the memory output and this is the address register output. This is the program program control output. This is the data register output and this is the accumulator register output, right? No output for the input register. Input register always send the information inside. Hence, this is the address register output and this is the temporary register output. This side, this is the temporary register input. This is the instruction register input and this is the data register input and this is the program counter input and this is the address register input and this is the input to the memory. Suppose we are going to be place some word, that is the selection lines, maybe for example, and I am going to be write load, like load for example 011. Actually, suppose 011 means in decimal this value is 3. This is the first register, this is the second register, that is third register. That means load the data into data register and send the data to the data register. So the data from the memory, fetched from the data from the memory and transfer in this way into the bus and transfer in this way through the bus and finally and circulating around the bus, like that, circulating around the bus like that, and finally loads into the data register. Here we have the three signals: load, increment and clear. So increment means suppose the data is incremented, clear means the data is cleared, suppose any data that is cleared in the register. Okay, this is the register common bus. For your reference, once again I show one more textbook diagram. This is like that. Okay, please observe carefully. Right, this is like that. Right, from the we can observe here from the memory, the address is also by using the starting the program consisting of the address. This address is transferred by circulating around this one and to the address register. By using this address, we fetch the instructions or data and placed on the common bus. Suppose that is the instruction by surrounding by and loaded into the instruction register. Suppose that is an address, sorry, data. The data is loaded into the data register and the data according to the instructions are processed in this accumulator. Sometimes the data is supplied from the input register. After processing, the accumulator places the results on the common bus. These are circulated around the common bus and comes to the output register. From output register to that is sent to the display unit. Okay, friends. For your convenience, I am also shown the actual diagram in the textbook and the process how the data is fetched. Here we are going to remember one thing again. The program counter always consisting of the next instruction is executing. For example, let us consider this is the memory. In this memory, this is the 10th location, that is A plus B. This is the 11th location, that is C minus D. So suppose In accumulator AC, the 10th, that means the AR consisting of the 10, that means address register. This instruction fetched from the memory and stored in the instruction register A plus B, and required data is stored in the data register. For example, 15 is stored in data register, and the instructions and data combinedly executed here in accumulator. So the currently executed instruction address in the address register, right? The next executed instruction is 11, right? The 11 is always in the PC. So the PC consisting of the address of the next memory location, the instruction to be executed. So this instruction is completed. Now the 11 is here to the address register and C minus D executed. At the same time, the PC is the address of the next instruction 12. Suppose the 11 is also executed, the 12 is transferred to the address register, the PC is updated to 13, address of the next instruction. In this way, the instructions are executed. Thank you.